Hey guys, welcome to the channel. We're going to be solving question 62 from the second chapter of the Hibbeler textbook. And in this one, we need to determine the magnitude and coordinate direction angles of the force F. So by magnitude, we need to find the magnitude of the F. And by this part, coordinate direction angles, we are referring to unit vector of the F. And we know the component of F in XY plane is 7 kilonewton, which is what we can see in the figure. So let's start with that, with coordinate direction angles or the unit vector. We can show it either with NF, we can show it with UF, and also we can show it with lambda F. These are all common. We can just go with UF. So let's find the F before that. And we know that each of these would be the F over the magnitude. So the F in a vector form divided by its magnitude is going to give us the unit vector or coordinate direction angles. So let's just find F first. And after that, if we divide everything by F, we're going to get unit vector. So let's see what we have for F in X direction. So for finding the X component, first of all, we have this right triangle here, which if we want to find the component on the XY plane, we have F times cosine of 30 degrees, since this angle is 30 degrees. So in this right triangle, if we want to find this component, we're going to have F cosine of 30 degrees. I'm just going to clean up the figure, we can see it better. So the 7 kilonewton that we have in here is basically F cosine of 30 degrees. And once we have that, it's easy enough because we have another right triangle here. And we can find the X and Y component. This will be the X component, and this will be the Y component. If you want to find the X component, we have the 7 kilonewton, or F cosine of 30 degrees times cosine of 40 degrees. And if we want to find the Y component, again, we have F cosine of 30 degrees times sine of 40 degrees, which is the other angle. And keep in mind that our Fy is in the negative direction of y, but our x is positive. And for finding the z is pretty easy because this will be the z component, and from the first part, or this triangle, right triangle, if you want to find the z component, it will be f sine of 30 degrees, which is this angle. So this is pretty much everything that we have. I'm just going to write down in here in a vector form. So our x is positive, as I mentioned, f cosine of 30 degrees times cosine of 40 degrees, or what we found in here, and that would be our y component. I'm going to show the y component in a different color. So as we can see, it's to the left, so we have a negative sign in here, minus f cosine of 30 degrees times sine of 40 degrees. That's going to be our j. And I'm going to show the z component, which is this one. It is upward, so it's in the positive direction of z-axis, so plus f sine of 30 degrees k. But that's not what the question is asking. The question is asking for unit vector, which means we have to divide each side of this equation by f, or by the magnitude. So what we get on the left side is f over f, which is what we were looking for at the beginning, or our unit vector for f. And we can cancel out all the f's in ijk, so we'll end up with cosine of 30 degrees times cosine of 40 degrees I, minus cosine of 30 degrees sine of 40 degrees j, and plus sine of 30 degrees k. So that's the part that we need to find the coordinate direction angles. So let's just calculate everything. So the unit vector in here would be cosine of 30 times cosine of 40. That's going to be 0.663 I. We have cosine of 30 times sine of 40. That's gonna be minus 0.557J, and we have sine of 30, which is 0.5K. And as we discussed in the previous video, so this will be cosine of theta x, this will be cosine of theta y, and this will be cosine of theta z. Each of them are the angle with positive side of x, y, z. So theta x would be cosine inverse of 0.663. Theta y would be cosine inverse of minus 0.557. And the theta z would be cosine inverse of 0.5. And if we want to find these angles, we can find the direction angles for this part. So that's another way of showing the unit vector, basically with going cosine of each of these angles with the axis we have for each component. So let's just figure this out very quick. So cosine inverse of 0.663, that's going to be 48.4 degrees. This one we have negative 0.557. It's going to give us 123.8. And we know cosine of 60 degrees is 0.5. So that would be the direction angles. Again, as long as we have the unit vector, we know what we have for I is cosine of theta x, and same for y and z. And we just have to do a cosine inverse of that value in order to find the direction angle. So the other part of the question was finding the magnitude. That's pretty easy. We actually figured out in here that f cosine of 30 would be the projection of f on xy plane. We already know that's 7. So basically our f cosine of 30 degrees is equal to 7. So we can find f pretty easy. 7 divided by cosine of 30 degrees. 7 divided by cosine of 30, which is going to give us 8.08 kilonewtons. All the units are in kilonewton. And yeah, that's going to be the final answer for this question. Hope everything was clear. Let me know if you have any questions. We are covering 3 different textbooks in this channel. Feel free to check out the playlist and let me know if you have any specific problems from these textbooks that you want me to cover in the next videos. And you guys take care. I'll see you in the next one.